Okay, so the final concept that we want to bring in is the mathematical equations for airway resistance, dynamic and static compliance. So far we've talked about the pressure times scalar, in which the reference point here would be 0. And we talked about the PEEP level that would go up to a peak inspiratory pressure, down to an inspiratory pause, giving us a plateau pressure, and then back down to the PEEP level after we got done. We also described that the pressure difference between the peak inspiratory pressure and the plateau pressure was the pressure used to overcome resistance in the airways. Okay. We talked about the pressure difference between the plateau pressure and the PEEP level is the pressure level used to overcome static compliance. And then the pressure level between the PEEP and the peak inspiratory pressure is the pressure level used to overcome dynamic compliance. Now, just by knowing this, you already understand the equations. Because if I were to say, what is static compliance? You would simply say static compliance is a change in volume over the change in pressure, which is the basic equation for compliance. But then on a mechanical ventilator, you would say my change in volume is my tidal volume. And then you would say my change in pressure is my plateau pressure minus my PEEP. Dynamic compliance, CDYN, is going to be equal to the change in volume over the change in pressure, which is going to equal your tidal volume, once again, divided by your peak inspiratory pressure minus your PEEP. And then finally, your airway resistance, you're going to say, well, the pressure gradient there is your peak inspiratory pressure minus your plateau pressure. And the other big factor is your flow rate to determine airway resistance. Now, students will get confused when we start talking about how these things interact. When we talk about a compliance dropping, becoming less compliant, you're saying it's stiffer lungs. And if the lungs are getting stiffer, then the pressure used to overcome them is going to go up. So if the static compliance drops, the plateau pressure will increase. If the airway resistance increases, then the pressure used to overcome airway resistance is going to increase. So when we look at these two changes, lung compliance, static compliance dropping, or airway resistance increasing, both of those will cause the peak inspiratory pressure to go up. If the peak inspiratory pressure goes up, calculated dynamic compliance is going to drop. Okay? So once again, dynamic compliance takes into consideration this whole scalar. Compliance dropping would mean stiffer lungs, meaning more pressure to push the gas in. Dynamic compliance includes airway resistance and static compliance. If static compliance drops, I guarantee dynamic compliance will drop. If airway resistance increases and static compliance stays the same, dynamic compliance will drop because airway resistance will cause the peak inspiratory pressure to go up.